Hey guys, welcome to another video from Foolish Engineer. Last time we saw all the basic stuff related to UART. If you haven't checked that yet, I think you should go watch that video first. This time we'll check the programmer's approach towards UART communication. This time we will see the baud rate and its importance, programming methods of UART, bit banging method and UART peripherals, how does the UART peripheral work, and finally we'll check the advantages, disadvantages and applications of UART. So let's go for a ride. To get the good handshake in asynchronous communication protocol, baud rate is very important. We have already seen the necessity of baud rate in the video of communication protocol in embedded system. If you haven't seen it yet, you can click on this card and watch the video. There are multiple baud rates in UART communication such as 9600, 115200 bits per second, and both transmitter and receiver need to configure same baud rates for proper handshaking. Now let's see how the data is being sent and how engineers program it. Well, there are two ways to do so. First is bit banging and second is UART peripherals, which are provided in the microcontrollers. Bit banging method is basic but quite difficult to work on. Let's say we need to transfer character A, which has binary as 0B01 000001, and we want to transfer this data using bit banging method with baud rate of 1 bits per second. So all the bits will be sent in a time of 1 second each. For this communication, we can use a normal GPIO of a microcontroller, set pin number 2. This pin will be connected to the receive pin of the other device, with which it has to talk. Initially pin 2 is high. When it wants to talk, it will go logic low, that is 0, for a single clock pulse, which is 1 second to notify the other device that the controller is about to send the data. Now the controller will start to send the actual data, and initially it will send the LSB of the data, which is 1. So pin 2 goes logic high. Then it will stay high for 1 clock pulse, which will be given as a delay in the microcontroller. The next bit is 0, so the pin goes low to logic level low and it stays there for 1 second by providing a delay. And further it will stay low for next consecutive 4 cycles to denote 4 zeros to the next device by providing delay at each cycle. Then it will get to logic high, then logic low, and 8-bit data is shifted to the next device. And finally pin 2 goes to high to stop the communication. And that's how the bit banging UART communication works. This is a quite lengthy process. Well, most of the controllers provide peripherals for UART. So programmers configure this peripheral and it makes their life very easy. So what actually this peripheral is made of? Well, it's quite interesting. There are two devices who need to talk with each other, right? There are particular blocks in each device, which are the transmit register, which is connected to the shift register, and it has one receive register, which is also connected to the other shift register. And both of these shift registers are connected to the clock signal of the device. Same blocks are arranged in the second device as well. This transmit register will send the full data stream to shift register altogether, which is called as parallel in. And this shift register takes this data and send it byte by byte to the next device. This operation is called as parallel in serial out, and the opposite process is being completed at the receiver side. This shift register takes all the data serially one by one and sends this data to the receive register all at once, which is known as serial in, parallel out. Let's look at this shift register. As we were trying to send the character A in earlier example, we'll do the same here as well. So we'll load the binary data into the transmit register and send the whole data packet to the shift register. And data will be loaded in the shift register like D0, D1, D2 and so on. And the shift register will send each bit one by one, synchronizing with the clock pulse to the receiver device. The same way, for the other device who is receiving, this data will come byte by byte, and this shift register will push whole data after receiving parallelly to the receive register. The clock is very important for this communication. It makes sure that the baud rate is configured properly for both devices. At each clock pulse, both transmitter and receiver lines transmit and receive data respectively. So we understood how this UART peripheral works. Now let's see how a programmer will configure this UART. The first step of this communication is to configure the clock of the UART peripheral according to the baud rate. After that, the programmer needs to load the data in the transmit register. Next step is to turn on the timer, so it will start putting the data from the shift register to the transmission line, and the other device will get the data according to the sampling rate. And after that, we have to monitor the data transmission. There are two methods to do so. First is the looping method and second is the interrupt method. In looping method, when data needs to be sent, then we have to monitor the status bit, which informs whether 8 bits are sent or not. Same goes in the receiver end, where it should monitor until all the data is delivered. In interrupt method, we don't need to monitor the status continuously, because when the data is received or transmitted successfully, a particular interrupt is generated in the code, to which an interrupt service routine will respond. So, interrupt method has advantages over looping method because our code doesn't stuck at the same place. We can complete the parallel actions in the system. For example, we are sending the data from first device to second. While sending, we want to execute some parallel operations, say blinking some LEDs. If you use looping method, then the data will be transferred from one device to another, and after that the LEDs will blink because our software is busy monitoring this data. But if you use an interrupt method, the data will be sent and it can blink the LEDs simultaneously for us. And when the data is transferred, it will just generate an interrupt. There are multiple advantages of this UART communication. So if you see, it is very easy to interface. It needs less hardware. Only 2 wires make a job easy. And there are no software complications like addressing the slaves, because only 2 devices are talking to each other. However, there are some disadvantages as well. For synchronization, baud rate of both devices need to be common, and that's where the limitations come. If one device has a lower capacity baud rate and other device can support higher baud rates, still we will need to go for low baud rates to which the first device supports. UART uses ad hoc communication topology, so there is no room for third device in this communication. And even after sending the data, we don't get any acknowledgement from the receiver. So it becomes very hard to check whether the data is received to the receiver successfully or not. If you talk about applications, these communication protocols are used in simple applications which are intended to complete easy tasks like printers. Serial monitors of Arduino are used to get the status of a system. Next, UART is also used for some systems such as command line interface like AT command interface in Bluetooth modules and GSM modules. So, that's all about the UART communication protocol. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you like this video, subscribe to my channel, and finally, thanks for watching.